Today we're going to talk about covalent compounds. Covalent compounds, we should know, are made by two or more elements bonding together in which they share the electrons. So covalent compounds share electrons. So we're sharing electrons in covalent compounds. Today our focus is going to be on naming and writing your chemical formulas and then drawing your Lewis dot structures. So that's the three things we'll examine with covalent compounds today. So first we deal with using the formulas to get the name. After that we'll move on to using the name to get the formula, and finally we'll draw a couple of Lewis dot structures. So when we're naming covalent compound, this is when you need to use your prefixes. You should know those prefixes by now, hopefully. If you do not, make sure you review those prefixes and get to know those prefixes. So for this class, you need to know 1 through 10. So make sure you know 1 through 10. Today we're starting off with N2H4 as our first example. So when we name that, we want to identify first what the element is. So in this case, the first element, you look on the periodic table, you see N is nitrogen. So we write down nitrogen. It's got two of them, so I should have left a little room here. So we got nitrogen, then you need your prefix. 2 is di. So dinitrogen, that di tells us we have 2. Then we move on to our second element. It's hydrogen. This time, to just make sure of space, I'm going to start with my prefix. I got 4 of them. So the prefix for 4, make sure you know, is tetra. So we have tetra. And then when you name covalent compounds, we just use the element name. For the last name, you want to change the ending to IDE though. So instead of hydrogen, it ends up being hydride. So we end up with hydride. So instead of hydrogen, we change the ending to hydride. So we end up with dinitrogen tetrahydride. That tetra stands for the 4. So make sure you're familiar, you know those prefixes. Second example, we have P3F9. Same process, P3F9. The prefix there is 3. So for 3 is tri, just like a tricycle or a triangle. Tri, and then P is phosphorus. Use your periodic table, you should see phosphorus on there, if I can spell it right. So we use triphosphorus, and then we see F9. F9, we need the prefix for 9 first. Hopefully you know it's nana. So nana for 9. And then again you change the ending to IDE, just like we did up here. So we change that ending to IDE, and we end up with nanofluoride. So nanofluoride. So triphosphorus, nanofluoride. So I misspelled phosphorus, but we can live with that. So triphosphorus, nanofluoride. Next one, we're going to do the opposite. So this time we have the name and we need the formula. So up here it gave you the formula, you need a name. Now we have the opposite. It gives us the name and we need the formula. So trinitrogen. So first you see the element is nitrogen. So we do N. And then we use the prefix to get our subscript, 3. So trinitrogen and 3. And then hexafluoride. So hexa, we should know, is 6, just like a hexagon. And then fluoride, we just saw up here, it was F. So F, and then we have 6 of them. So N3F6. So trinitrogen hexafluoride. Finally, we'll come down to our Lewis structures, drawing our Lewis dot structures. First one we have is PCl3. Remember, when we draw these, we want to try to make them symmetrical if possible. So we want to make this one as symmetrical as possible. So in this case, we're going to start with the P in the middle, and then draw our CLs coming off of it. So we start with the P, draw our CLs coming off of it. I'm going to do 1 up, 1 left, 1 right, and 1 down. So we get P in the middle, and then 3 CLs coming off of it. Next, you have to do your valence electron count. So you look at each element in your bond there. First one is P. So we have 1 of those P's. And then you look on the periodic table, you see what group it's in. P is in group 15. So that tells us that it's got 5 valence electrons. So we do 1 times 5. 1, the number of atoms, times the number of valence electrons for that element. So 1 times 5 gives us 5. Then we do the same process with the next element in it, Cl. So we have Cl. How many of those do we have? 3. So we do 3 times the number of valence electrons. So you look on your periodic table, you find chloride. We see it's in group 17. Get the valence number, you just take that group number, minus 10, and we see that it's got 7 valence electrons. So 3 times 7 gives us 21. So then, once we have all of our valence electrons, we're just going to add those values up, and we'll get 26. Then we come back to our diagram, and we see that we've used 1, 2, 3 lines already. Remember, each line counts as 2 electrons, so we subtract those 2 for each one. So 2, 4, 6, we subtract 6 off our value there, and we end up with a total of 20. So we use that 20, and that's how many dots we can put on this diagram. If we use all 20, and everything's full, then we're good and we can stop. If we do not have 20, then we're going to have to go back and make some changes. So in this case, remember all the elements want to be full, stable, with 8 electrons. Your one exception is hydrogen, which is full with just 2. So hydrogen should never need dots because one line would fill up. So then we look at this diagram. We'll start in this case in the middle because a lot of times people forget the middle if they don't do that first. So we'll start with the P. It's got 1, 2, 3 lines. Each line counts as 2, so it's got 2, 4, 6. So to get to 8, we need 2 more. So we put 2 dots on it. Then we go to the outside. We have chlorine. It's got 1 line, so a total of 2. So to get to 8, we need 6 more electrons. So we do 1, 2, 3, 4, 5, 6. We put 2 dots on each side for a total of 6. So 2, 4, 6. So we have 8 total electrons counting the line. So 2, 4, 6, 8. So that one's stable. Then we go down to the Cl. Same process. It's got 1 line is 2. And then we add our 6 dots. Finally, we come to this Cl. And again, we see it's got 1 line, so it needs 6 electrons. 1, 2, 3, 4, 5, 6. So then we count our dots. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've used all 20, so that's a good diagram. So we end up with a diagram that looks like that. That's our structure for PCl3. That's what we call a Lewis dot structure. Next we'll come over to our last one up here, CO2. Again, we want to try to make it symmetrical. So in order to make it symmetrical, we're going to put the C in the middle and then have the 2 O's coming off of it. So we put our C in the middle, and then we have our 2 O's come off of it. One going to go left, one going to go right. So we put 2 O's off of our C. Then we have to do our valence electron count. So we have C's, carbon, and carbon you see is just 1. So we do 1 times the number of valence electrons. You should see carbons in group 14. So 1 times 4 gives us 4. Then we do our O's. We see we have a total of 2 O's. You look on your periodic table, you see oxygen is in group 16. And that gives us 6 valence electrons. Again, the group number minus 10 for those. So then 2 times 6 gives us 12. And we just have to add those values up. So 12 plus 4 gives us a total of 16. So we have 16 dots with 16 valence electrons. To figure out how many dots we can put on them, we subtract the lines we're going to use. We've used 2, 4. Each line again counts as 2. So now we have 12 dots we could put on here. So we can go ahead and start adding those dots. Again, I'm going to start in the middle and work my way out. So we have C. Got 2, 4. Again, each line is 2. So 2 and 4. So we put dots on it to get to 8. It needs 4 dots. So we've used 4 dots. That means we have 8 left to use. So then we come over to this O. It's got 1 line. 1, 2, 3, 4, 5, 6. So we put 6 on that. So 4 on this one, 6 here. We've used a total of 10. We have 12 we can use. I can only add 2 more dots. And if I look at this last O, it's got 2 on it. To get to 8, I'm going to need 6 more. I can't do that with just 2 dots. So we're going to have to do something different. This isn't going to work, so we're going to have to do something different. So what I'm going to do is just erase your dots. If you're doing it in pen, you have to redraw it, so it makes it a lot of times pencil may help. So then we look at this diagram, and we look at how we can do it. Remember we talked about double bonds. So again, we want to try to keep it symmetrical. So I'm going to put a double bond on each of them. That would keep it symmetrical. If I just did one, it wouldn't be symmetrical. This is going to be symmetrical. Sometimes you may add two and have to go back and erase one. That's fine. You're more likely to need both of them. So keep it symmetrical if you can. So then we come back and we have to subtract those two lines we added. So -4, we added 2 lines. So now instead of 8 of 12, we only have 8 dots to put on here. So again, I'll start in the middle. C, it's got 2, 4, 6, 8. It's got its full octet. It's got 8. So now we're going to move on to the outside where we have these O's. So first this O, 2, 4. It's got 2 lines, which is 4 electrons. So it needs 4 dots. That means to get 8. So 1, 2, 3, 4. So that one's full. Then we come over to this one. And again, it's got 2, 4. It's got 4 to it. So it needs 1, 2, 3, 4 dots to get to 8. So now we have our 8 valence electrons. They all have the full octet. And we've used 8 dots. That's how many we had to use. So we've used our full set of valence electrons. So in this case, we ended up having to use 2 double bonds to make that CO2, that carbon dioxide. So this is your review of covalent compounds. Make sure you can write the names using your prefixes. You got to know those prefixes, so make sure you can use those prefixes. Make sure you can write the formulas. Formulas should be easy if you know your prefixes. It gives you the name right there and tells you the number. You just write down the name and the number that it tells you. Not too much to that. And then make sure you can draw your Lewis dot structures as well. So make sure you're looking at your valence electrons. Again, we try to make them symmetrical if you can. Not always going to be possible, but try to make it symmetrical if you can. Thank you, and hopefully that helps you with your covalent compound.